Okay, so we're going to look at probability with combinations. So combinations, order is not important. Permutations, order was important. So we're going to look at the number of combinations and then at the time. So is it going to be repeated the number of times? This is going to be n factorial, and this is divided by n minus r factorial multiplied by the number of times that an object is taken. So this could be the number of combinations. So if we had 8 objects, we could say that we have 8 objects and we're going to take 3 at a time. So we would write this as 8 factorial. The number is 8 and is minus 3 factorial multiplied by the number of time, which is 3 factorial. So this then would become 8 factorial over 5 factorial multiplied by 3 factorial. And if we work this out, so this would be 8 times 7 times 6 times 5 times 4 times 3 factorial. And this is 5 times 4 times 3 times 2 times 1 times 3 factorial. So the 3 factorials cancel, the 4 cancels, the 5 cancels, 3 times 2 is 6 cancels. So we're left with 8 times 7, which is going to be 56. And this is 56 combinations. Okay, so an example, invitations. Amna is inviting 6 of her 20 friends to join her at a theme park. If she chooses friends at random, what is the probability that Shaitha, Hessa, Fatima, Nora, Sarah and Afra will be chosen? So we're going to use NCR. So this is the number of combinations at a time. So the number we have is, we have 20 friends. So this is going to be 20 factorial divided by 20 minus, and the possible choices we have is 6. So this is going to be R. So this is going to be 20 minus 6 factorial multiplied by R, which is 6. So if we work this out, so 20 factorial divided by 14 factorial times 6 factorial. So 20 can be written as 20 times 18 times 19 times 18 times 17 times 16 times 15 times 14 factorial. And this is over 14 factorial times 6 factorial. Now our 14s will cancel, and we can work this out. So 6 factorial, just going to rewrite that. So 6 times 5 times 4 times 3 times 2 times 1. And 5 times 3 is 15. And that's all we can do. So let's work this out. Or we could put 20 factorial divided by 14 factorial times 6 factorial straight in the calculator. Or actually what we could have done with this, we could have said instead of cancelling the 15, We could do 6 times 3 was 18 and 5, 4 was 20, which means that we wouldn't have simplified the 15. But if we put this in to a calculator, we're going to get 38,760. So this is combinations, possible combinations. And if we want to find the probability that she chooses the 6 are going to be those girls, then this is going to be 1 out of 38,760. Okay, we have a geometry problem. If 3 points are randomly chosen from those in the rectangle shown, what is the probability that they will lie on the same line segment? So we need to use NCR. So this is going to be the number of our combinations divided by n minus r factorial multiplied by r factorial. So let's have a look at the question. So it says 3 points are randomly chosen. So the number at a time is going to be 3. So how many choices do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 choices. So we've got 8, and we're going to be choosing 3 at a time. So this is 8 factorial divided by the number 8 minus 3 factorial multiplied by 3 factorial. So 8 factorial divided by 5 factorial multiplied by 3 factorial. So we can simplify. So 8 times 7 times 6 times 5 factorial over 5 factorial times 3 factorial. So we've got the 5's will cancel. And then we have 3 factorial. It's going to be 3 times 2 times 1. 3 times 2 is 6. So we've got 56 possible combinations. Now the question says, what is the probability that they will lie in the same line segment? So we need to find out how many line segments we have. So this is 1, 2, 3, 4. So it's going to be 1 out of 4. So it's going to be a quarter of 56, which is is 14. So combinations. And if we write that as a probability, this will be probability of 1 over 14 being in the same line segment.